Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over the addition rule for statistics. So if we look at number 1 over here, we've got the first iteration of the rule saying that when the events are mutually exclusive, meaning that one thing cannot be both A and B at the same time, we've got the probability of A union B is equal to the probability of A plus the probability of B. So we can use that in our example 1 down here. So suppose an experiment consists of tossing a fair die once. What is the probability that either a 1 or a 5 is rolled? Okay, so the first thing we want to do with this problem is figure out what the probability of rolling a 1 is and what the probability of rolling a 5 is. So first, the probability of rolling a 1, because it's a fair die and there's only one 1 on the die, we've got 1 in 6 as the probability there. And similarly for 5, there's only one 5 on the die and there's 6 sides, so the probability is 1/6. So now the question is asking what the probability that either a 1 or a 5 is rolled. So that tells us we're finding the probability of a 1 or a 5. And using the rule, because these events are mutually exclusive, you can't roll a 1 and a 5 at the same time. We're just going to add the probability of a 1 being rolled and the probability of a 5 being rolled, which will be equal to 1/6 plus 1/6, or 2/6, which we can reduce to 1/3. So our answer here, the probability of 1 union 5 is 1/3. So moving on to number 2 over here, we've got the second iteration of the formula, stating when the events are not mutually exclusive, meaning that you can get one element from the sample space being both A and B. The probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So let's do example 2, knowing that. A table outlining the results of a survey is provided. What is the probability of a randomly selected person being either male or responded yes? So when we get a table like this, what I like to do is add up all the rows and columns to figure out how many people total are in each of those. So let's start with the male column. If we add up the yes and the no from the males, we get 24 total males. Doing the same thing with the females gives us also 24. Now doing it with the yes row, we've got 25 total yeses, 5. And the no's give us 23 total no's. And knowing all of those totals, we have an overall total of 48 people that were surveyed. Okay, so the next step in this problem, because we're finding whether someone is either male or responded yes, we're going to find each of those probabilities individually. So the probability that they're male is going to be the 24 total males, 24, divided by the 48 total people in the survey. So 24 over 48. We could reduce that, but it'll make the problem easier if we don't right now. So next, we want to figure out the probability that they said yes, which will take the total number of yeses divided by the total number of people. So 25 over 48. And finally, because of this second iteration of the formula we need to figure out the probability of A intersect B, or in other words, the probability of male and yes. So we can find that by looking at the table itself. We can see here, we've got the yes column here, and the male, or the yes row and the male column. Those intersect here to give us 10 total people that are male and responded yes. So we'll have 10 over the total 48. And now we've got all the blocks to use the formula that we know. So finally, we're going to have the probability of M union Y, in other words, male or yes, and we'll fill in the formula. So we've got the probability of male plus the probability of yes minus the probability of male and yes. So we can plug in the numbers that we know now. The probability of male is 24 over 48 plus the probability of yes, which is 25 over 48, minus the probability of M intersect Y, which is 10 over 48. And this gives us a final answer of 39 over 48. And that's about it. So you'll just want to make sure at the beginning of a problem you figure out whether the events are mutually exclusive or not, and that'll kind of tell you which of these formulas to use. Thanks for watching.